Welcome back, dear students, to this new lesson of the chapter data structure. Welcome to the channel Byte by Byte, where you are going to learn all what you have to know for advanced level in the computing subject, that is ICT, computer science. Today, lesson is centered under evaluation of arithmetic expressions. As you can see, it is still under a stack because we are primarily using a stack to evaluate these expressions. Without wasting so much time, let us dive into the lesson. Mathematical expressions are written with the operator between the two operands, as in 1 plus 2, because as you have 1 plus 2, 1 and 2 are known as the operands, whereas this plus is known as the operator. And this format is what we call the infix, that is in between. That we call it infix, where the operator or the sign, if you want, is in between the two operands. An alternative used by some are the prefix and the postfix. Let us understand what these two new notations are, because I am sure since primary till now, we are just used to this type of notation. Postfix or reverse Polish notation (RPN) is one where the operator follows its operand. That is, in other way, it is the notation whereby the operator comes after the operand. Prefix notation is one where the operator comes before the operand. So it's an error here. The operator comes before the operand. That's why we call it prefix. Consider the infix expression a plus b. As you can see, you see that our operands are blue and our operator is red. So if it is the equivalent postfix, you see that our operator is now after. So it is going to be ab plus instead of a plus b. This is the postfix. You see that the operator comes after the operand. The equivalent prefix expression is going to be plus ab, prefix, that is the operator first before the operand. When we have complex expressions, there is a set of accepted rules that determine the way the expression should be evaluated. The order of precedence of the operator is given below. Like in class 5, you were taught about BODMAS, bracket of division, multiplication. As we move further, we saw other variables such as the modulus, the power function, the power operator, sorry. And now we need to know how to properly use these different operators, their order of precedence over the others. The number one is the bracket. Anything in the bracket is done first. Number two, the powers. Powers and roots are done next. So if there are no brackets, the operator will have to prioritize are the powers and the roots. Remember that roots are simply powers, but in a rational way. Division and multiplication are next. Equal precedence, that is, division and multiplication have equal precedence. Order is left to right. What does this mean in bracket? Very pertinent. If I have division and multiplication, they are of the same precedence. We move from left to right, meaning that if I have division first before multiplication, I perform the division. If I have multiplication before division, I perform the multiplication. It's not that division is always before multiplication. No, they are of equal precedence, and we are reading from left to right. Addition and subtraction are done last as well. Equal precedence. Order is left to right. So addition and subtraction have equal precedence. Now, let us take as example. As you can see here, we have 4 plus 10 divided by 2. We are seeing that what division have precedence over plus. So I first of all divide. As you can see, 10 divided by 2, 5, before I perform the addition. And I get 9. So you see that I prioritize because division have precedence over addition. Next example, as I have 4 times 10 divided by 2, you see that my two operators here are multiplication and division, but they are of the same precedence. So the first thing is to perform the multiplication. Get 40 before I divide by 2 and I get 20. Some students will come and say 10 divided by 2 is 5, 5 times 4 is still 20, the same thing. But when it will come to expression trees or converting from prefix to postfix, it might not be the same. So always follow the order of precedence. Example 3, 4 minus 10 plus 2, we have subtraction and addition. And we know that addition and subtraction have the same precedence. And I first of all operate what is on the left. 4 minus 10 is negative 6. Negative 6 plus 2 is negative 4. That is the answer. Another student who will be wrong will come and say 10 plus 2 because in both maths addition comes before subtraction. He will say 10 plus 2 12. 4 minus 12 negative negative 8, which is going to be wrong. Subtraction and division are of the same precedence. So I perform the subtraction first of all to have negative 6 here. Then negative 6 plus 2 to get negative 4. Example 4, 4 minus 10 plus 2, as you can see, it is true that multiplication subtraction comes before addition, but they are in the bracket, and bracket are done first. So 10 plus 2 to give 12, then 4 minus 10 minus 12, sorry, to have negative 8. That is how we follow the precedence of the operators because it is very vital. It is with this precedence of sign that we can easily convert from infix to either prefix or postfix. Conversion from infix to prefix and postfix. To carry out this process manually, you can use the fully parenthesing method. What is it all about? Let us understand it through these examples. Convert the infix expression below to the precise expression in bracket. We have postfix, prefix, and postfix. Let us proceed. 7 plus 8 times 6. The first operation I will perform is the multiplication because multiplication has precedence over addition. That's why you have this. And now since you are in postfix, how do we convert in postfix? It is the operand first before the operator. So this is going to be 8 6 times. As you can see, so when we talk of fully parenthesis method, once you evaluate something, you put it in bracket so that we should understand that it goes as a single unit. So here I'm having 8 6 times. Now, some students usually confused because student will come and say that now I have 7 plus 86, then I have times. No, please, dear student, be focused. 8 6 times is now one entity. Let me just use a simple substitution for you to understand better. If 8 6 times was x, it means that this is going to be 7 plus x, and 7 plus x in postfix is what? 7x plus. And since x is this, that's why my answer is going to be what? 7x times plus. That is my final answer. Let me take it back. 7 plus 8 times 6. We follow the precedence. It is multiplication first. This is the multiplication here, as you can see. So, postfix, operand before operator. That's why I have this one. Now, if you let this to be x, I'm letting this to be x just for you to understand that this goes now as a single unit. So this is x, meaning that I have 7 plus x. 7 plus x in postfix is 7x plus. So now when I move from this to this, I put back the value of x, which was 86 times. That's my final answer. So 7 plus 8 times 6 in postfix is 7x6 times plus. The next question, this is what we have. And we see that what? We are in the bracket because we have expression in the bracket. Now, in the bracket again, you realize that I have three operators: multiplication, power, addition. And between them, it is power that comes next. That's why you see it is in blue. For you guys to know that this is the variable, this is the operation that is to be performed first. Now, 4 raised to the power 3 in prefix. Prefix is what? The operator before the operands. So I'm going to have what? Raised to the power 4, then 3. This is what I get. So for this one, this is here, raised to the power 4 3. And I put it in brackets for you guys to see that it goes as a single unit. After performing the power, the next operator with precedence is multiplication. That's why you see it in red. And what am I multiplying? I am multiplying this man, which is this, with 5. That's why they are in blue. For you guys to actually trace what is going to be evaluated next. And now in prefix, when I take this and this, what am I going to have? The operator first times, then the left operand 5, and then the right operand, which is what? Raised to the power 4 3. So this together will give me times 5 raised to the power 4 3. That is what I have, times 5 raised to the power 4 3. And now after I'm done with this, I'm still in the bracket. So the next operation is with this plus 9. So now this being a single entity, because as I'm getting new entity, I put them in bracket. That's why we call it the full parenthesis method. Now I'm going to have this man, the operator first plus, then this entity, then I will have 9. So I'm going to have what? Plus times, that is the operator plus, times 5 raised to the power 4 3, then 9. That is what I get. And now I am going to add this with this. The operator first plus, then the left operand 6, and finally the right operand. So I'm supposed to have plus 6 with all of this, and that is my final answer. Plus 6 plus times 5 raised to the power 439. The C part, as you can see, I have three different sets of brackets, so I can evaluate them all together. That's why you see them in blue and their operator red. When I express postfix here, what am I going to have, dear students? Perfect. AB plus. What of this one? Correct. CD plus. And finally, yeah, awesome. DE times. So this is what I have. And now after that, now I have division and subtraction. And from here, we see that division have precedence over. So I'm going to evaluate this first of all. And since we're in postfix, I will have this man, then this man before the operator. So I'm going to have AB plus CD plus division. That's what I have. Then all of that minus this man. And since you are in postfix, I'm going to have this man, and finally a subtraction. So I'm supposed to have AB plus CD plus division, DE times subtraction. So that is what I have as the postfix result of this expression. Pay attention, dear student. A quick notice I'm going to give you, which can help you in some cases. You must take note that when you are converting an infix expression to a postfix expression, the first character must be an operand and the last must be an operator. And that should be the reverse for a prefix. In a prefix, our first should be an operator, the last an operand. As you can see here, this postfix, operator. No, sorry, operand, operator, operand, operator, operator, operand. So those are some of the signs you can use to know whether your answer can be correct or not. We proceed, dear students. Evaluation of postfix notation using a stack. Yes, that's why we are having this. We are still under stacks. How do we evaluate a postfix notation using a stack? This is a concept that is very vital for advanced level candidates. To evaluate a postfix, that is RPN expression, one efficient method is by using a stack. One efficient method, not the efficient. That is why, as the founder of the channel Bye Bye Bye, I make sure I do some research in order to favor the community, to favor you, dear students. One efficient method is by using a stack. Recall that a stack is a leaf-4 data structure. The method is as follows. Evaluating the expression from left to right, always. When you encounter an operand, push it onto the stack. So when you have an operand, we push inside the stack. When you encounter an operator, pop two values from the stack, evaluate them with the operator, and push the result back into the stack. I hope you are okay. That is what. So when we have an operand, we push inside the stack. If you have an operator, we pop out two values. Remember that pop is used to remove two values from a stack. We evaluate them and we push back the result in the stack. When you have finished, that is, been through the whole expression, pop the final answer from the stack. Evaluate the RPN expression 12 for division, 8 times 7 2 subtraction, addition, using stack and showing the content of the stack during the process. So you must evaluate this postfix expression. Postfix because, as you can see, the sign, the last character is an operator. Okay, what do we have? This is our stack because we always start with an empty stack. Our first character is 12. So I push 12 because 12 is an operand, and when it's an operand, we push in the stack. So our first character is 12. I push in the stack. Next, 4. I push in the stack because it is still an operand. Now I have a sign, division. And we said that once you have a sign, we pop out two values, we evaluate them. And when you're evaluating, it's the one below operator, the one above. So as I have division, it's going to be 12 divided by 4 and not 4 divided by 12. No, 12 divided by 4. So as I have my operator, I pop out two values, I evaluate them. 12 divided by 4 gives me 3. And I push now the result into the stack. As you can see, that's what we have. So I pushed 12 and 4 first of all. As I had my sign, I popped them out. Normally, you're supposed to have 12 and 4 here, but I just make them to disappear for you guys to understand what is happening, because at the end of this exercise I'm going to give you the content of the stack. So we have evaluated and we had 3. This is what we have. The next is 8. It is an operand. We push in the stack. The next is an operator. We pop out 2 values. We evaluate them. 3 times 8, 24, and we push the result in the stack. That's what we have. Next, 7, we push in the stack. Next, 2, push in the stack. Next now is subtraction. So I pop out 2 values. Dear students, which values am I going to pop out? Which operation am I going to perform? Perfect. I'm going to pop out 7 and 2, because when we are popping out values, we are popping from the top. So I'm going to pop out 2 and I'm going to pop out 7. And now the operation we have is 7 minus 2 and not 2 minus 7, because I told you it's the one below operator, the one above. So I'm going to pop out the 2 values and I have my 7 minus 2, which is 5. So I'm going to push my result back inside here. So I will have 5 above. This is what we have, dear students. The next one now is addition. I pop out 2 values and I evaluate them. So 24 plus 5, 29. That is what we have. So that's the content of the stack. So this operation, this notation evaluates to 29, dear students. I hope it was clear to understand and very easy. And now this is the content of the stack at the end of the evaluation. So I push 12 and 4. Once I have a sign, I put the operation down so that my marker will know what I am doing. After having 3, I put the 3. The next one was 8. You push 8. Then you have multiplication. You pop them out. 3 times 8, 24. You push the result. Then 7, then 2. You have subtraction. You pop out 2 values. 7 minus 2, 5. You push back the result. Then addition, 29. So this is how your solution is supposed to be. You can decide to remove this stack if you want, but you need to know how you are putting the values and the operation you are performing before moving to the next stack. So that is what we have for this solution. We proceed. Remember, we said there it is one efficient method because there are other methods. Evaluation of postfix notation using sliding. Slide. You remember when you were kids, you usually go on some type of small hills. You use a big container, then you slide down. As easy as that. That's just how this method is, and very sweet. Another way to evaluate RPN expressions is by sliding operators into place and evaluate them. So slide. Here are the steps. Take the leftmost operator and slide it in one place to the left. That is, you just move it one place to the left, because when you are moving one place to the left, automatically it will be in between 2 operators. Apply the operator to the operand on either side and substitute the result. Repeat the steps above until you are left with a single operand, which is going to be our answer. Now let us look at the example we had. Remember that this gave us 29 as answer. Let us see how we can use sliding here. Very easy, dear students. So we said that we take the leftmost operator, and in this case, the leftmost operator is division. That's why you see in red, for you guys to actually follow what we are doing. So as I have division, we said that take the leftmost operator and slide it one place to the left. So when I slide it one place to the left, this is what I'm going to have. What is 12 divided by 4? Dear students, 12 divided by 4 is 3. Apply the operator, this is that we apply, we had 3 on either side, and substitute the result. When we substitute the result, it means that what from this operator right to the left will be replaced by this man. So division 4, 12 will be replaced by 3. So this is what we are going to have, as you can see. So these 3 are replaced by the result. That's what we have. The next leftmost operator, multiplication, we slide it again to the left. When we evaluate, 3 times 8 gives us 24. So 24 will replace 3, 8, and multiplication for us to get this. The leftmost operator is what? It is subtraction. We slide it to the left, one place to the left. This is where it's going to come. So we shall have what? 7 minus 2, which is 5. And 5 replaces what? The 2 operands and the operator. So 5 will replace 7, 2, and subtraction. And I'm going to get 24, because this 24 that we have. This 1, 2, 3 are replaced by 5. Then I have plus. The last operator, I slide it one place, and I have 24 plus 5, which is 29. So that's how we still have the same answer. So please, dear students, put in the comment section which of the methods you find easy to use. Is it using a stack? or using sliding? I am waiting for your comments, dear students. Note, these two different methods are similar to converting RPN into an infix notation, with the difference that the operations are not performed. What do we mean by the operations are not performed? At this level, since it gives me 12 divided by 4 and the result is 3, if I'm converting to an infix notation, instead of having 3, I will simply have a bracket, and inside that bracket, I'm going to have 12 divided by 4. So here, I will maintain 12 divided by 4. 3 times 8, 7 minus 2, 24 plus 5, in such a way that at the end I'm going to get an infix notation and not the result of the notation. As Let us take this question, the Northwest Regional Mock 2021 question 2 sub 1. I will give you 2 minutes to look at the questions. Okay, dear students, let us proceed. The A part is asking, give one application of reverse Polish notation. RPN can be used in financial calculations, scientific calculations, computer programming, statistical analysis, etc. So these are some of the applications of RPN. The B, convert the expression that into RPN. So they are indirectly asking us to convert into infix. And you are not evaluating. So what do we have? First of all, I have 3 sets of brackets, like the third example we had. So when I evaluate this, what am I going to have in postfix? Perfect. 323 plus. And now, guys, when you are given this type of question and you are having numbers of more than 1 digit, I will advise you to use a comma to separate them so that you are not going to be confused. So, what am I going to have? 300, 23 plus for this one, that is the operand first, then the operator. For this one, 43, 21, operator, which is subtraction. Then here, 84, 7 plus, as you can see. Now, after evaluating the bracket, we are left with multiplication and division, and they are of the same they are of the same precedence, meaning that we move from left to right, and the left operator is multiplication. So this is the first one I'm going to perform, and that will give me this man 323 plus, then this man 4321 minus, then finally the operator. All that divided by 84.7 plus. So my postfix is going to be this operand followed by this operand followed by the operator. So I'm supposed to have 323 plus 4321 minus times 84.7 plus division. And that is my final answer, dear students. I hope it is clear and understood. We move to the C part. Convert the expression ABC star D divided plus E minus FG divided HE plus divided plus into infix expression. So we can either use a stack or a sliding, but we are not operating. First of all, we cannot operate here because they are just variables. So what do we have? This is my expression. Remember that when I have an operand, I push in the stack. If I have an operator, I pop 2 values, I evaluate, and I push back the result. So in my stack, I have my A, I push B, I push C because I have 3 operands. Now that I have an operator, what are the values I'm going to pop, dear students? Perfect. B and C. So I'm going to have B star C. So I pop out these 2 values. Then I evaluate them to have B star C. Then I push back the result. So this is what I'm going to have. So these 2 values are being popped out to have B times C. Then the result is pushed back. Then I have D. Then I have division, meaning that I'm going to remove D and B star C to evaluate them. This is what we get B star C, all that divided by D. Reminder again, it is the one below operator, the one above. So this is what we have. These two are removed and they will be replaced, and this one is going to be replaced by this. So I have my A, then B star C, all that divided by D. After the division, I have addition, meaning I'm going to have A plus what is above. As you can see, double bracket. So this is my content of the stack, because after the addition there is E which is being pushed. Then I have my subtraction, meaning I'm going to have all of this minus E. That's what we have. Sorry, this is a problem. We're supposed to have all of this minus E. So this is what we have. Sorry, it's supposed to be all of this minus E. It's an error here. I hope you guys saw the error because it's the one below operator, the one above. So I'm supposed to have all of this minus E. Then I push F, I push G. Now I have division. So I'm going to pop out F and G to have F divided by G. When we proceed, we have F on G. Then I push in H, I push in I. Then I have addition. So I'm going to remove H and I add them, as you can see. So next, I have this. Then these two were popped, evaluated, and the result pushed back. After the addition now, I have division. So I'm going to pop out this and this. That gives me F on G, all that divided by H plus I. This is what we get. And finally, I have addition. So I'm supposed to have this plus this. And that is my result. And dear students, as I told you, it's supposed to be all this bracket minus E and not the reverse. So that is the answer. The D part says, consider the following arithmetic expression x written in postfix notation, translate it into infix notation and calculate the result. So you saw how to use a stack to convert from infix to postfix. Let us also see how to use sliding to convert postfix to infix. So this is what we have. The leftmost sign, 7 minus 3. As it moves, I'm going to have 7 minus 3. You see that here I am not evaluating because here they ask me the result of the computation, but here I am converting to infix. So I'm not evaluating. It remains like that. Now I have my division. Division enters. So I'm going to get 12 divided by 7 minus 3. The next leftmost sign is addition, which enters in between 1 and 5. So this is what I'm going to get. So as it enters here, I have all of this. Then I have 2. Then 1 5 plus is replaced by 1 plus 5. The next one is multiplication, which enters in between 2 and this bracket. So I'm going to get all of this. Then these 3 are replaced by what we are seeing here. The final one is addition. So my result is 12 divided by 7 minus 3. All that plus 2 times 1 plus 5. That is the infix expression. And the question says, and calculate the result of x. When we compute, this is 4. So 12 divided by 4, this is 6. 2 times 6, which gives 3 plus 12, which gives us 15. Advantages of RPN. RPN expression do not need brackets and there is no need for precedence of operators. Very correct. Remember that when we were evaluating this expression, there was no order of precedence. We were not doing like we are checking. No, we simply evaluate, applying the rules. The next one, RPN is simpler for a machine to evaluate. Correct. The last one, the least but not the last, because there are other reasons, there are other advantages. There is no need for backtracking in evaluation as the operator appear in the order required for computation and can be evaluated from left to right. Perfect. So there is no need for backtracking, meaning that we are not going to look at, are we doing this before this? No. We evaluate as the operators are coming. Exercise, dear students. In Northwest Regional Mock 2022, question 8 sub 1 C. Evaluate the equivalent infix expression to the postfix. Evaluate the equivalent infix expression of the postfix. So you have to convert this to infix. Feel free to use the method of your choice. And then here they said evaluate the following arithmetic operations. So as you can see, the operator are the last. So these are postfix expression. And since there are 3 of them, I will like, dear students, that you should vary. Either you use 1 with sliding and 2 with stack, or you use 2 with stack and 1 with sliding. It depends on you. We are coming to the end of this video. I hope it was a good one, that you learn more through this video. Do not forget to like, to subscribe, and to share our videos to your classmates, to your colleagues, in order to increase our community. And why not dropping a comment which will serve as a feedback to your instructor that I am. Thank you very much. See you in the next lesson.